All right, welcome to the first video of CS 499 Network Science. This is Dr. Vigil-Hayes. So even though everything else in the world is changing, I am still the instructor for this course. That has not changed. So this week's video series will focus on structural assortativity. So that will be our topic. This will correspond to chapter 7 in your text. And to start us off, I will go over a little bit of administrivia. So first and foremost, make sure that you are on our Slack. There's a lot of important announcements and help threads that are available there. Specifically, I started 2 new channels. So I started an announcements channel and a weekly check-ins channel. The announcements channel is where I will be making announcements related to the latest COVID-19 situation as it pertains to the policies and the mechanisms of our class. So you can see there's already been a few announcements. I was kind of posting there as we were finding out that we are going to be moving the rest of the semester to online mode. There will probably be some information about how we'll proceed with our final exam schedule and process. So just make sure that you're checking that channel for new announcements. I also created a weekly check-ins channel. So the weekly check-ins channel is going to be really important, especially as we start navigating learning online together. So weekly check-ins is a way for you to engage with the course content in this side channel. So for example, if you have any major questions about content that we've covered, or if you have any major questions about labs or things, activities that correspond with the content that we're covering or with the reading, this is the place where you're going to send those questions. What I will be doing is in preparation for office hours and in preparation for our class check-in time on Wednesdays, I will be looking at the questions that you pose, and I'll make sure that I will be able to answer to some of the most frequently asked questions. And then if it's a one-off question, hopefully I will be able to help answer it, or your classmates. So it's a really good place for you not only to ask questions, but also to test out your understanding by answering questions. One of the well-researched ways of ensuring that you have a good understanding of a new concept is when you try to explain or teach that concept to somebody else. So you can kind of see answering questions for your peers as a chance to self-test your new knowledge. In addition to questions, a really good way to use the weekly check-ins channel would be to post exam-like questions. So as you're going through the new content, we've already practiced doing exam-like questions for 2 different exams now. We're going to be doing the same thing for final exams. The biggest difference is that now we're all online and we're kind of in this asynchronous mode of operation. So what I would love for you to do is to think about exam-like questions that would map to this new content that we're covering in each week, and kind of come up with those questions incrementally rather than all at the end of kind of a module of topics. So I really think that this will help solidify the concepts for you. So I highly encourage you to do that. Second, I will be checking email, I will be checking the Slack channels, and now I will be checking Slack DMs. So if you need to get in contact with me, if you have something that's personal that you feel like nobody else really needs to know about, or it's not appropriate for the entire group, it's not a question that other people might be asking, go ahead and email me or DM me in Slack. Um, I am kind of expecting our email servers to have some glitches as we move online. So, yeah, that's why I'm now going to be checking Slack DMs. If you have, general questions, please go ahead and put that in the Slack channel. That way, you give your peers an opportunity to help answer that question. It's a good learning experience for everyone. For email, please review the syllabus on email policy. Please, please, please use in the subject line the code word CS499, no spaces, all one word. I have a special filter set up on my email to filter these to a folder, and I check these on the hour during the workday. I'm really good about checking it. If you don't use that code word, it is so likely that your email will get lost in the deluge of emails that I am currently working through. As you can imagine, it's probably the same for you. I'm getting so many emails about, what we're supposed to be doing for COVID, not only in the NAU context, but also for the other research communities that I'm involved in. So, um, I really, really want to be responsive to you, so please make sure that you're following the policy for email. And then just another final note on communication. Let me know if you are experiencing any challenges that I can do something about. So this can range from things like, hey, Dr. Vigil-Hayes, I'm having a really hard time understanding content as we've moved to this new format, and maybe we can work together to come up with some accommodations or some supplementary ways for you to help understand the concept. Um, if you have challenges that are logistical, maybe you're somewhere where you don't have reliable internet connectivity, um, we will figure that out together. I've been thinking about this a lot. So, if that's an issue, please let me know. If you're sick and you just can't tune in to our weekly check-ins, please let me know. We will figure out a way to help you catch up, make up work. I really want to know about anything that will affect your learning experience, and I want to partner with you to make sure this is the best experience possible given these crazy circumstances. I care so much about your learning, and I just want you to feel very comfortable reaching out to me if there's anything that you feel like is getting in the way of that. Obviously, besides the actual virus, which I cannot come up with a vaccine for, unfortunately, but I can do my best to make this course something that works for you. All right, so all of that aside, let's get on to the nitty-gritty. So it might surprise you that today's topic is opening up with two pictures of celebrity couples. So if you've ever been in the grocery store back in the olden days when we would go and stand in lines at the grocery store, you might remember seeing tabloid magazines or, People magazine or Us Weekly. And there would always be pictures about celebrities with headlines about who's dating who's breaking up with who. And one of the things that you might notice is that these headlines typically refer to romantic partnerships that strike up between two celebrities, or three celebrities sometimes. But usually it's always celebrities, right? We're never really hearing about some famous person connecting to, the average Joe. It's always about the connections between celebrities. And it seems like celebrities tend to like to date other celebrities. Maybe there's a bias in what we know about that, but that's something that the casual observer might say is true. And maybe you don't really pay attention to those tabloid magazines. Maybe you're more of a Forbes person, And maybe you've noticed that a lot of high ranking CEOs tend to have social connections. Oftentimes, they'll serve on the same boards, advisory boards for running other companies, or advisory councils to, national or nonprofit organizations. Oftentimes they're friends, so like Warren Buffett and Bill Gates have this really nice friendship relationship. So again, it's another example of two very high-ranking, highly connected individuals having a link between each other. And so, if we were to take away an observation, a general observation from these two cases of social networks, we might say that high degree nodes tend to form links with other high degree nodes. Um, and so the rest of today's lecture is going to be unpacking that observation just a bit and introducing us to the topic of this week. So as network scientists, whenever we make an observation, maybe you've noticed this already, we always want to investigate the extent to which a pattern or an observation holds true. So let's go ahead and make the following hypothesis and test it with other real-world data sets. So we've already tested out the hypothesis, high-degree nodes always form links with other high-degree nodes. That definitely seemed true in the celebrity dating network. But let's go ahead and test it against a different data set. So let's look at a network of brewer's yeast protein interactions. So in this network, which you can see here, the nodes will be proteins, and two proteins will be linked if there's an experimental evidence that they can bind to each other in a yeast cell. All right, so in this network diagram, in gray, we've highlighted two nodes and their neighborhoods with the largest degree value in the network. So I'm going to give you 5 seconds to write down some observations about this network. All right, so maybe one of the really interesting things that you've observed, given our hypothesis, is that the two highest degree nodes are not linked to each other. So this totally goes against our hypothesis, which means that we would need to reject our hypothesis. So what does that mean? Well, instead of being a hard and fast rule about how high degree nodes tend to link to each other, maybe our observation can be a useful way for classifying different types of network structures. So in the next videos, we will learn how to map networks into these three categories. So the first category is where hubs tend to link to each other. So examples of that would be social networks, dating networks, so where celebrities tend to date each other, and non-celebrities tend to date each other. So my husband and I are decidedly non-celebrities, and we ended up turning out just fine. We also have a tendency for hubs to link together in collaboration networks. So famous scientists tend to work with other famous scientists. In contrast, there's a different type of network that we observe when we're looking at, how hubs tend to link with other hubs. And this is the case where hubs tend to not link to other hubs. So one example that we just looked at was the protein interaction network. And this is actually this holds true as a pattern for a lot of protein interaction networks. When we look at metabolic networks, this is also a common case. So when there's when you're looking at the interactions between enzymes, for example, we tend to not have a lot of interactions um, between hubs. And then there's a third category where hubs neither tend to link together nor not link together. So an example of this would be a power grid network where it's determined more by proximity, like geographic proximity, than it's related to, structural relationships. So for example, a power grid at Chicago might be connected to power grids that are in more rural parts of Illinois. Whereas the power grid of New York City might be connected directly to the power grid in Jersey City, which is also a very large city. So it's just more a factor of how close geographically places are rather than how similar the size of their power grid might be. So, as we start to talk about these three categories, we actually have technical names for them. And these are the names that are related to the characteristics of structural assortativity. So, that's looking at how likely nodes are or unlikely nodes are to connect to each other based on their local structure. So the first category is assortative networks. So these are networks, again, where hubs tend to connect to hubs. The next category is disassortative networks, and this is where hubs tend to not connect with other hubs. And then finally, we have neutral networks, and this is where hubs neither tend to connect to other hubs nor not connect to other hubs. So it's really hub size is irrelevant when forming connections. So in the next few videos, we will learn how to determine which class different networks belong to. So if we look at a network, is it an assortative network? Is it a disassortative network? Or is it a neutral network? So we'll be able to do this both with real networks, but also we'll be able to do this with network models that we've generated. All right, so this is the end of the first video. Please feel free to post any questions about it in Slack, and I look forward to moving forward with the topic with you. All right, bye.